this video is going to be on 4.3. Technically, this is going to be part F, okay? And this is really, this part is going to focus on, in part E, we focused on identifying hyperbolas, understanding the equation of a hyperbola, and how to identify the vertices, the foci, the center, the asymptotes, and then graphing them. In this section, we're going to be utilizing various things like the center or the foci and or the vertices or the asymptotes, and we're going to utilize those to try to identify what the original hyperbola equation is. So what we're doing here is trying to write the equation from given information. So this is a little bit more challenging than just drawing the hyperbola, I think. These slides are going to start with, although there's 21 slides, we did 1 through 10 in part E, and then I think 11 to 21 is going to be part F.
So at this point, I just need you to skip ahead to slide 11.
Slide. So in this 11th slide here, we're going to find the equation of a hyperbola. So we're going to use the information given to determine if the hyperbola is vertical or horizontal. Okay, we're going to find the center. We're going to find the A and the B value. We're going to use the formula C squared equals A squared plus B squared to try to find the missing A, B, or C value that we need. We know that the transverse axis is 2 times A. Remember the transverse axis, that's the length, basically, the length of the segment, let's say, between the two vertices. And we learned that in the last thing, but you don't really need to know that, I think. The conjugate axis is 2b, not worried about that one. So let's see what we're talking about here. So again here, and I feel like on this, a little sketch is always helpful. So they're telling us that our foci is located at -3, 0 and 3, 0. So first of all, -3, 0, here, there's a foci, and +3, 0. That's the other foci. So already that tells me if my two foci are on the x-axis, I know that this is going to be a horizontal hyperbola. And so already, again, knowing it's a horizontal hyperbola, remember that I know it's x squared minus a y squared equals 1. I know a squared is going to go with the first term always, and the b squared is going to go with the second term. And since it's a horizontal, the x squared is first. So I already have a little bit of information with this. Now, we also know that our foci are c units away from the center. So I know the center is here at 0, 0. So I know that my center is located at 0, 0. And I know that my foci is 3 units in both directions, right? This is 3 units to the right, and this one's 3 units to the left. So I know that my C value equals 3. Okay, I know C squared is obviously 9. I don't think I need to know that, but just in case. Then it tells me that my vertices is at -2, 0 and 2, 0. So again, my vertices here is at -2, 0 and +2, 0. And so again, I know the distance between the center and the vertices is my A value. So that means that A is 2 units and A squared is 4 units, right? So last thing I know, if I have C squared and A squared, I can use my formula. C squared equals A squared plus B squared. 9 equals 4 plus B squared, which means B squared equals 5, right? And that also means B equals positive or negative square root of 5. But again, I don't know that that's going to matter right now. But look at all that I can already do. I can already come back here, and I know A squared is 4, and I've got y squared over b squared. B squared is 5 minus 1, or equals 1 rather. And so notice I have my hyperbola, my equation of my hyperbola. I don't need to know anything else. They didn't ask me to graph it. They didn't ask me to graph asymptotes. They just wanted me to find the equation. And so this is the equation. So again, remember, all you're doing is finding the equation. So it might feel a little incomplete because you're not listing a whole bunch of things like you did in the first half of the video or part 1 or part A, but at the end we know that this is, you don't always need everything. So again, I have to sketch a little bit with what's given to kind of give me a visual of what I'm doing. This tells me the vertices is at negative 1, 0 here and at 1, 0 here. So vertices, vertices. So already that tells me that I'm dealing with a horizontal hyperbola, right? Which means it's going to be an x squared minus a y squared equals 1. And I know that, you know, a squared goes under the first term and b squared goes under the second. So I know that the center is located in between. It's the midpoint between the two vertices. So I know my center is at 0, 0. So my center is at 0, 0. And that tells me that my A value, which is the distance between the center and the vertices, is 1. So I know that A equals 1. So I know that A squared equals 1 squared or 1. So I'm just going to go filling in, right? I know that's 1. Y squared. Now I still need B squared, right? So let's see what else I was given. It tells me that my asymptotes are located at negative 4x and 4x. So I know that since it's a horizontal hyperbola, right, I know the asymptote of a horizontal hyperbola where the center is located at 0, 0 is plus minus b over a. Now, if this is plus minus 4 or 4 over 1, I know your instinct is to do 4 over 1 and assume, oh, b is 4 and a is 1. And in this case it is, because we do know that a is 1. But know that it might have been, 8 over 2, which also is 4 over 1. And in this case, b would be 8 and a would be 2. So you have to be very careful with that, okay? It simplifies down to 4, positive or negative 4 over 1, but it might not actually be the original a and b value may not be 4 and 1. In this case, it is. Because you know that a is 1, we know that b actually does equal 4 then, okay? So we know that b is 4, which means b squared is 16. So now I'm ready to just pretty much come back here and write it again. X squared over 1 minus y squared over 16 equals 1. And that's my entire equation. And I didn't really have to do a whole lot. I don't need to know the focus. I don't need to know my, draw my asymptotes or draw it. This is all I needed. So again, each time you're going to be given different pieces of information to try to conclude the equation of your hyperbola. Again, all they want is the equation. So again, I look at what they give me, and they tell me that the foci is at 0, negative 5 here, and at 0, 5. So what you're going to notice is it's on this vertical axis, and so I know that this is a vertical asymptote, or vertical hyperbola, okay? And what that means is that the y squared is going to be first, right? And I know that it's going to be over a squared, and the x squared is going to be over b squared. Remember, the first term is always over a squared. So I look over here at my, well, before I even move over to this and this, right, these asymptotes, what does the foci tell me? Well, remember, the foci is the distance from the center or the C value is the distance from the center to the foci. So first of all, I know that the center is in between this, which would be at 0, 0. So I know my center is located at 0, 0. And I know that my C value is going to be, the distance here is 5 units. So C is going to be 5, which means C squared is going to equal 25. So that's something, right? I have my center, I have my C, let's see what else I've got. Okay, so then let's see what else they give me. They tell me that my asymptotes are negative 3, 4x and positive 3, 4x. So again, this is a vertical hyperbola. I know the formula for this is plus minus a over bx. So I know right now, right, I have a over b is going to be plus minus 3 over 4. So I know here that a could be 3 and b could be 4, but again, it could just be simplified down, to 3 and 4. So remember, I know that 3 over 4 is going to equal a over b, and if I cross multiply, I know that 3b is going to equal 4a. So I could solve one for the other. I could divide both sides by 3, and I could get b equals 4a over 3, right? So I could have, a equals a, right? And b equals 4a over 3. Now, why is that important? Well, because I could come over to my formula, a squared plus b squared equals c squared, and I could say, okay, a is a squared, b squared would be 4a over 3 squared equals c squared, which is 25. Notice that now that I'm going to have a single variable problem here. So I'm going to get a squared plus 16a squared over 9 equals 25. This could be 9 over 9a squared if I want to give it the same denominator. And this would be 25a squared over 9 equals 25. And again here, then I'll multiply by 9 25ths. 9 25ths. And I'm going to get a squared equals 9, which means a equals plus minus 3. So a squared does equal 9. Okay, equals 9 in this problem. So now I know what a squared is, and now I can do the same thing, and I can solve for b squared. So I've got, again, a squared plus b squared equals c squared. A squared is 9, c squared is 25. And so I'm going to get plus b squared equals 16. So b equals plus minus 4. But again, all I'm really looking for is b squared. So notice, if I do a over b, right, I'm going to get plus or minus 3 over 4. But that wasn't the actual AB value. Like, I wasn't sure what that was, right? Now I confirmed it, and yeah, a is 3, b is 4. This wasn't actually just a simplified version of it. So a squared is 9 and b squared is 16. So again, I just had to confirm that it was 3/4 and negative 3/4 and not simplified down to that. And that's the way you do it to solve, for a and b. Now that again that I solved for it, I know here that my equation, now I just have to fill it in, right? So it's going to be y squared over a squared is 9 minus x squared over b squared is 16 equals 25. Not 25, equals 1, sorry, equals 1. And that's the equation of my hyperbola. So again, when you have that 3/4, you just have to make sure that it's not just simplified down to that, okay? All right, so again, find the equation of the hyperbola, and again, we get here to, let's just kind of draw it out. Our vertices is 0, negative 2, and 0, positive 2. So here's my vertices, here's my vertices. So again, I know my center is at 0, 0. and I know that my it's going to be a vertical asymptote. Okay, it tells me that my point is going to go through, a point that it's going to go through is -2 and 5. And so again, that's going to be a y value that I might be able to use in the future. This is one of the ordered pairs that happens to be on one of these hyperbolas. So again, let's think about what that would mean, right? I know that the equation is going to be x squared, or no, it's going to be a y squared because it's vertical. So it's going to be y squared over a squared minus x squared over b squared equals 1. And so one thing I know that I can do here, I notice that the distance between the center and my vertices, this is my a value, is 2 units. And so I know that y squared over 2 squared, right? If a equals 2, then a squared equals 4, right? So it's over 4 minus x squared over b squared equals 1. So now notice the only thing I need to figure out here is what b is going to end up being, right? But if I have a point, -2 and 5, I have an x and I have a y. So I can actually plug those in. So I can actually do that y value of 5 squared over 4 minus that x value squared over b squared equals 1. So I can just kind of do the math here. I get 25 over 4 minus 4 over b squared equals 1. I could subtract 25 over 4 to both sides, right? So I'm going to get -4 over b squared equals, I'm going to convert 1 to 4 over 4. And I'm going to get -21 over 4. And I will multiply both sides, I guess, by b squared, right? B squared here and b squared here. I'm going to get -4 equals -21 b squared over 4. And I'm going to multiply both sides by 4 over -21. Like that, right? And I'm going to get, this is going to cancel, this is going to cancel. I'm going to left b squared. This is going to be -16 over -21. So b squared equals 16 over 21. And again, I don't have to go any further from that. All I needed was b squared. So again, now that I know that it's that, then I'm going to come here and do y squared over 4 minus x squared over 16 over 21 equals 1. Now this would be acceptable for me, but again, we don't really like complex problems. So I know that I could do state change flip to this second fraction. And if I did that, I would get y squared over 4 minus 21x squared over 16 equals 1. And that's another way. It's probably the better way. But that's the answer. So again, I had to plug in the x and y into here and here since I already knew my a squared, and then I could solve for my b squared. So all of these are different. You're given different things. You're going to have to be careful on what you're given and how can you use it to find whatever is missing. So I'm just going to keep doing the same thing, right? Every question is the same in the sense of they want me to find the equation of the hyperbola. Now the equation is going to always be x squared or y squared first over a squared minus the other one over b squared equals 1. And so I just have to figure out, I need to know basically a and b. So over here it tells me the x-intercepts of my graph are positive and -3, 0. So 1, 2, 3, 0, and -1, 2, 3, 0. So they tell me these are my x-intercepts. I'm assuming that what they're telling me there is that those are the vertices, but I just want to make sure. So let's look at where my foci are. Notice my foci are at ±5, 0. So my foci are here, foci, vertices, and -5. And so I know then that, yeah, that these x-intercepts, these are my vertices, okay? But I still needed to make sure, okay? So again, I know that my center is the midpoint of those, and so this is vertices and foci as well. That point right there at 0, 0 is my center. So my center is at 0, 0. Again, remember that the distance from the center to the vertices is your A value. In this case, it's 3 units, so A squared is 9. The value from the center to the foci is your C value, and here I know that's 5. So I know C squared is 25. And so I'm able to do, I know that C squared equals A squared plus B squared. So 25 equals 9 plus B squared. So I know B squared equals 16. If I have B squared and I have A squared, I'm pretty much done. I know this is a horizontal hyperbola. So I know that x squared is going to go first. A squared always goes below the first term. My y squared is going to go second. The b squared goes under that one, equals 1. And that one's really quite easy. Okay, so I come over to here again, find the equation. I'm just going to do a quick little sketch and try to figure out what they're trying to tell me here with the given information. They tell me my y-intercepts are 0, 9, and 0, negative 9. So here's 9, here's negative 9, and I know that these 2 points are my y-intercepts. My foci go higher up on my graph, right? My foci goes up to, let's say here, 15, and it goes down to negative 15. So foci, vertices, vertices, foci, and my center is at 0, 0. And so once again, this one's going to be pretty straightforward. This is a vertical asymptote, or vertical hyperbola, okay? Which means then that the y squared is going to go first with the a squared, and then the x squared will go second with the b squared. It equals 1. I know here, again, the distance from the center to the vertices. I know my center, right, is at 0, 0. I know the distance from the center to my vertices is my a value, and I know that that is 9 units. So a squared equals 81. It's important. I know that my c value is the distance from the center to my foci, and that's 15. So c squared equals 15 squared, or 225. It's important. And I know, again, that all I need now is to figure out b squared. So I know that c squared equals a squared plus b squared. 225 equals, a squared is 81 plus b squared. So I'm going to subtract 81 here. I'm going to get 144 equals b squared. And I'm good there. And I have everything I need. It's going to be y squared over a squared minus x squared over b squared equals 1. And there is my equation of my parabola. And I don't have to graph, find asymptotes, or do anything else. Again, we keep looking, come up to my information given, and I'm probably going to recommend that you do a little graph, right? And I see here that my vertices is located at plus or minus 10, 0. So 10, 0 here, and negative 10, 0 here. It's my vertices. So I already know that this is a horizontal hyperbola. My center, again, is at 0, 0. And I know the equation is going to be an x squared over a squared minus a y squared over b squared, and it equals 1. So I know that the distance between the center and the vertices is my a, so I know that a equals 10, which means a squared equals 100. So x squared over 100 minus y squared over b squared equals 1. So the only thing I have left to find here is my b squared. So I don't have enough information just yet to find b. However, they gave me the asymptote, and once again, they told me the asymptote was plus or minus 5x. So because it's horizontal, I know my asymptote equation, okay, is going to be y equals plus or minus b over ax. So I know that b over a is going to be equivalent to 5 over 1. And so, like we talked about before, we know that b could be 5 and a could be 1, but b could be, 10 and a could be 2. So this is just a simplified version. Thankfully, we already know that a is 10, right? So we know that b over 10 is going to have the same ratio as 5 over 1. And so now I'm going to be able to use this ratio to identify my b value, right? So I'm going to get 1b equals 50. So b is 50. So b squared is going to be 2,500. And so now I have everything I need for my equation. X squared over 100 minus y squared over 2,500 equals 1. Okay, so again, this 5,1 was a simplified version of the actual b and the actual a. Thankfully, since we had this a, we were able to find the correct b value. All right, so we keep going again. Here, again, we have a vertices located at 0, -5 here, and 0, 5 here. So we know this is a vertical or hyperbola. I don't know why I keep saying that. A vertical hyperbola. We also know that the center is again in the middle of those 2 points here. So this is a vertices center. Center's at 0, 0. And we know that the equation is going to start with y squared over a squared minus x squared over b squared equals 1. And we know that the distance between the vertices and the center is our a value, and it's 5 units long. So we know that a is 5, which means a squared is going to be 25. So I can already sort of come here, and I can start to simplify this a little bit, right? This is 25, x squared, b squared equals 1. And so again, you're noticing the only thing missing here is the b squared part of it. Now, I don't have the c value, I don't have asymptotes. What I do have is that my graph passes through a point which has an x and a y value. So if I can use those x and y's in this equation, I can find b squared. So that's what I'm going to do. So the y value in that point is 10. So this is 10 squared is 100 over 25 minus, and then the x is 3, so 3 squared is 9 over b squared equals 1. I can even make this a little simpler. 100 over 25 is equal to 4. So 4 minus 9 over b squared equals 1. I can subtract 4 from both sides. I'm going to get minus 9 over b squared equals minus 3. Let's make it over 1. I'm going to multiply both sides by b squared. Let's do that, right? B squared here and b squared here. And I'm going to get minus 9 equals minus 3b squared. And I'm going to divide both sides by minus 3. And I'm going to get b squared equals 3. And now that I have b squared, I can plug it back in there. So the final answer is going to be y squared over 25 minus x squared over 3 equals 1. And there's the equation to my hyperbola. Again, there's a lot of information here that I didn't find. The asymptotes, the c, the foci, but I didn't need to. To find the equation of the hyperbola, I only really need a squared and b squared, and I need to know which one goes first in the numerator. So whatever I need to do to get to that, that's what I need to do. Okay, find the equation of the hyperbola yet again. And notice all of these have had a center of 0. I think all of them except the last one is going to have a center of 0. So again, the foci here, we have plus or minus 3 radical 5, 0. So here is positive 3 radical 5, 0, right here, right? That's a foci. And then here, negative 3 radical 5, 0. And here is my center in the middle. So again, if my foci are on my x-axis, I know this is a horizontal hyperbola. I know my center is located at 0, 0. I know the c value is the distance between the center and the foci. So my c value is 3 radical 5. So I know that c squared equals 3 radical 5 squared, which equals 3 squared is 9 times 5, or 45. So c squared is 45. So that's what I got from that. And then it tells me my asymptotes. And so again, well, let me just kind of write what the equation is going to look like. It's going to be x squared first over a squared minus y squared over b squared, and it's going to equal 1. So in this problem, I still need my a squared and my b squared. Now I'm told that my asymptote is y equals plus or minus 2 over x. Well, in a horizontal hyperbola, I know that the asymptote is always y equals positive and negative b over a x. So I know b over a here is equal to 2 over 1. But once again, I don't really know if that's a simplified version, right? Is b really 2 and a 1, or is b 20 and a is 10? And it doesn't matter. So I am going to need to figure that one out. So if I take this equation here and I cross multiply, notice that you're going to get b equals 2a. So I could take this, I know the formula c squared equals a squared plus b squared. So if I know that c squared is 45, a squared is just a squared, right? And b squared, I'm going to substitute for b, I'm going to substitute 2a. So it's going to be a squared plus 4a squared, or 5a squared. So 45 equals 5a squared, and if I divide both sides by 5, I'm going to get that a squared equals 9. And so guess what? I got my first new value. I've got a squared equals 9. So now, again, I come back to my whole c squared equals a squared plus b squared. If c squared's 45 and a squared's 9, I can easily solve for b squared. B squared is going to equal, I'm going to subtract 9, and I'm going to get 36. And so now I have all three things. So my equation, my final equation, is going to be x squared over a squared, which is 9, minus y squared over b squared, which is 36, and it equals 1. And so that's kind of a roundabout way that we can use to find this answer. And again, notice that you do not want to use just the general slope as b and a, because this would have told me that a was 1 and b is 2. And it's not, right? It ends up being that when I do the math, a is 3 and b ends up being 6, okay? And 6 over 3 is 2, but again, very different values. Okay, and then the last one, and this one you're going to notice here that you have a center that's located somewhere other than 0, 0. So that's kind of cool that we finally got one of those. So notice that your vertices are at 5, negative 2, right? 5, negative 2 here, and 1, negative 2 here, okay? And so what you realize is that, again, if those are your two vertices, you know that your hyperbolas are going to go through that axis line there. So again, you know that your center is going to be in the middle, or the midpoint of those 2 points. Well, the midpoint of 1, -2, and 5, -2 is going to be at 3, -2. So I know that my center is going to be at 3, -2. So notice that that's my H and that's going to be my K, right? And I know the distance from my center to my vertices is my A value. So I know my A value is going to be 2 units, which means A squared is going to be 4. Okay, so that's, again, pretty important stuff right there. Now, I know my equation, right? I know this is going to be a horizontal hyperbola. So I know it's going to be an x minus h squared over a squared minus a y minus k squared. Or, not squared. These aren't squared. Over a b squared, right, is going to equal 1. And yeah, I don't know why I took the squares off. It is squared. So it's going to look like that, right? And I already know that a squared is 4. And I know that my center is 3 and -2. So I can kind of do this as well. I know my center here is going to be x minus h squared over a squared, which is 4. And my y minus k is -2, so that's y plus 2 squared over b squared equals 1. And so notice the only thing missing here is my b value. So let's see. All this information that I garnered here all really came from these two vertices. Let's see how the asymptote can help us, right? And remember, it's y equals, this is the k, and this is the x minus h. I like to move the k over, so this is a y plus 2 equals plus or minus 3 over 2 x minus 3. And so again, this kind of reconfirms that our h is going to be positive 3 and our k is -2. So I definitely have the correct center. And I noticed that it's a horizontal hyperbola, which means this is plus or minus b over a. So b is 3 and a is 2. And here, if I simplify it, but again, that's not always the case. I did, however, I was able to identify, right? I know that b over a is 3 over 2. And in this problem, a does happen to be 2. So b must equal 3. Okay? So b is 3 here. And so if I know that b equals 3, then I know that b squared equals 9, and I'm able to finish this off. So again, I've got x minus 3 squared over 4 minus y plus 2 squared over 9 equals 1. And so again, I was able to do it. So there, again, you have to understand it to be able to figure out what to take from it. You have to know how to use the asymptote formula to identify your slope. It's either going to be your actual slope or it's going to be a simplified version, like a ratio of your slope. And again, you've got to be very careful with that. I think this is it. You're going to just need to get practice with it. You're going to need to know how to take what's given and represent, is it a vertical or a horizontal asymptote? Then, can you use the foci or the vertices or both to find the A and the C values? Can you find your center, right? Once you find your center, your A, your C, you can then work to find B. And if you're not given the foci and the vertices, a lot of times what they're going to give you then is the asymptote. And again, you have to know how to use the slope of the asymptote, that formula, that b over a or a over b, depending on the type of hyperbola. Then you're going to have to be able to use that to find your a and your b. And that's it.